All right, so the purpose of this video is to introduce and discuss the first level of Concept Builder, Solve It, Inclined Planes, the apprentice level. This is a classic inclined plane question, and this is also my notes, more or less, of introducing inclined planes. I apologize for the movement all over the place, and there we are. So we're coming back around to the force of gravity. This has been a never-ending source of confusion, it seems like, so I'm going to touch on that as well. But we have multiple things we're trying to form here, but we're starting with some information. We have a mass given to us of an object accelerating down a friction-free incline. We're forgetting about friction in the beginning. We have an angle of 21.3 degrees above horizontal. So anytime I'm doing this, I always recommend drawing a picture. In this case, they've drawn the picture for us. This is not clearly labeled, so I would definitely label that 21.3 degrees. And it's also worth noting that when you're doing this, this angle here is also 21.3 degrees. If you're a person of geometry, I can show that why that is. If you have an inclined plane and you have the force of gravity going vertically down, and you have an angle of theta here, this force this way, which is called force perpendicular, it's at a 90-degree angle from that inclined plane. So if this is 30, this is, of course, a square angle, then this would be 60. And then if this right here is 90, then this would be 30. That's why these two angles are equal. Just if you're curious about the proof of that, which maybe you're not, but that's why that is. The truth of the matter is, you don't really too much need to worry about that angle because we have an equation that would tell us what this perpendicular force and the parallel force is based on this theta. And so this is going to be new to your notes. If you don't already have it, this equation, two equations rather. And that's right here. Force perpendicular is equal to force of gravity times the cosine of theta. Force parallel is equal to the force of gravity times the sine of theta. And this little sketch here should clarify, if I was putting this down as I was here, this is an equation. I would always want to make sure and clarify what is theta, what's the inclined plane, what's the force of gravity, what's the force perpendicular, and what's the force parallel. The cool thing about this is doing these problems explains why things roll. So we're going to bear those equations in mind. One other thing that has been a source of huge confusion that I want to touch on here, as I said, and we'll start with this, is we'll solve for the force of gravity. Now, the force of gravity, this is an equation that I've given. Whoa, I apologize. Oh, my word. The force of gravity is the same thing as weight. It's equal to mass times 9.8. It's also equal to mass times gravity. These are all things, mass, acceleration due to gravity, which is 9.8. So when we solve this, we'll just say the force of gravity is equal to mass times acceleration due to gravity. So the mass is 4.32 kilograms, and the acceleration due to gravity, that's what G is negative 9.8. So our force of gravity, so if we multiply that, we end up with negative 42.34. Now this would be newtons, as we fed in mass in kilograms and acceleration in meters per second. That would be newtons. We're not putting newtons in here because they're showing it there. But the force of gravity is downward. This is already showing downward, so I'm not going to put the negative in there. I don't believe physics classroom needs you to put the negative in. I don't even believe it'll allow you. but that would be the force of gravity. Now that we've solved that, we already know mass, 4.32. We don't know acceleration yet, and we don't know the net force yet. But what we can do is we can start looking at the force normal and force parallel and force perpendicular. Now the force normal is always equal in size and opposite in direction from the force perpendicular, because this is an object sitting on an incline. It's a box on a hill. Think about a man on a bike on a hill. Why is it things roll down hills? Why do things go down hills? Why is that? Well, this explains it in terms of forces. The hill or the incline can only push up. It can only push this way. That's all it can do. So to find force normal, we really need to find the force perpendicular. So, and we have our equation there. Force perpendicular is equal to force of gravity times the cosine, which means we are at 42.34 times the cosine of 21.3. So when you run that number, you're going to get 39.44. So the force perpendicular is 39.44. Therefore, we also know that the force normal is 39.44. Now to solve the force parallel, we're going to do an identical thing, except we'll do sine of theta. All right, so if you run those numbers, sine of theta, that should be 21.3. I should have written 21.3 there. You'll find 15.38. 15.38 is your force parallel. Now, the final question here that we need to think about is down here. We got to think about acceleration and net force. So this force net is really thinking about what is the net force on here. And on an inclined plane in a scenario like this, it's worth noting that the force perpendicular is going to be canceling out the force normal. So really the net force here is going to be equal to the force parallel, because parallel and perpendicular, they're really what this is. So it's kind of like the force of gravity goes away, and we're just looking at these two things instead of the force of gravity. And so if you're wanting to know the net force on this object, since you've accounted for the force of gravity by showing its components, these two components effectively cancel each other out. So all you're really left with then to see the net force is that force of gravity that's on it. And so what is the value of that? So your net force is actually equal to your parallel force in this scenario of 15.38. Now to calculate acceleration, we go back to our good old-fashioned equation from, good. Our good old equation from Newton's second law here, where the force net is equal to mass times acceleration. Force net equals mass times acceleration. We know our force net, we know our mass, and what we're actually solving for is acceleration. So if you solve for acceleration, you're going to find that 3.56 would equal the acceleration. Thank you. Like and subscribe.